Go.
All right. Although I'm making this for my son, anyone who's interested in arithmetic sequences are welcome to watch this. First things first are notation, and I think that's probably one of the things that's driving you nuts, Roger. Okay, first of all, this is often seen. That would be a sub 1, or the first term. That's all that little thing is right there. If I have this, a sub 2, that'll be the second term. If I'm going to keep writing a sequence, I might go all the way down to the point where I have a sub n, which is going to be just a theoretical, what would I do if I knew any term specifically, like the 20th term or so forth. I can plug in for n, okay? So that's the way the sequences go. This, however, what I'm about to do with you is called the explicit form, and we'll get into more of that later. All right, so if I have a particular sequence of terms, and let's see, yeah, if this is the sequence of terms, and I'm going to write it down here. So if this is the sequence of terms, let's say 2, 7, 12, 17, 22, and so on. If that's the sequence, obviously the first term, this is the first term. So this means that a sub 1 is equal to 2. A sub 2 is equal to 7. A sub 3 is equal to 12. The question is, what is happening here? Okay? One of the ways to tell that, honestly, is to look at from here to here, what's the difference? The difference is 5. I add 5. From here, what's the difference? It's 5 again. From here, what's the difference? It's 5 again. If you can add the same amount each time, that's when it's an arithmetic sequence. All right, so I'm adding 5 each time. That means when I get to a sub n, if I add 5 each time, have I added it once? Have I added it twice? Have I added it 3 times? So you see what's happening there. This becomes 5n. This and this are the same. So when you see D in a formula, that's the difference. Now, the question becomes, if I have a sub 1, does that, if I plug 1 in, here, will I get 5? No, I get 2. So I have to be careful that if this is a sub 1, although I have this done correctly, it's not going to yield the first term here. So I have to subtract 3. Why would I do that in this particular case? Because 5 times 1 take away 3 equals the 2 that we want. All right, so the bottom line, when you're writing an explicit form, okay, is that the difference, whatever it is, goes in front of the n, because that's how much it changes every time. And it's something that's additive, and repeated addition is the same as multiplication. That's why you need this. What you have to do over here is to figure out, what will I have to do to this formula or this expression so that it equals literally each term as I go. And if you think about it, 5 times 1, take away 3, that gives you 2. 5 times 2, which is 10, take away 3, that gives me 7. 5 times 3, which is 15, take away 3, will give me 12. If I keep going, it'll work. And it'll work no matter how many terms up I have to go. So if I were asked for the 20th term, I would just have to go 5 times 20 take away 3 would equal what? It would equal, I'll put it down here, 100, right? 5 times 20 is 100. Take away 3, so the answer will be 97. That's a lot easier than having to write out 20 terms to find it. You certainly could, but that's where these formulas will help. So that's the basic introduction to an arithmetic sequence. Whoops, put an E in there. Thank you.